In Wade 1021A, we're creating, the goal is to create carbon-carbon bonds, and one of the methods to do that is something called a Gilman reagent. If we have ethyl chloride, add lithium, lithium will throw its electron in there. We're going to get an intermediate actually where you would end up with this, and the chloride comes out, and then the copper inserts there. We don't need to go into the specific details, but the bottom line is when you have two equivalents of this ethyl chloride, add the lithium, add the copper iodide, and we will now get this, what's called a Gilman reagent. In this case right here, you have the copper, the lithium, and the two ethyl groups here. 1, 2, 1, 2. These two ethyl groups, 1, 2. Now, lithium wants nothing to do with its electrons, so it's going to force it onto the copper. But then copper is a metal, and it doesn't want electrons. So basically, what you have over here is electrons going off, and you can think of this as an ethyl group with a negative charge, that carbon right there. Now there are two of them, but only one of them is going to actually be added. So this is now a really strong nucleophile. When you have, and then we go ahead and we add 1, 2, 3, 4, 5, 6, and then we have, for example, an alkyl bromide like that. This can go ahead and do an SN2 reaction, and when all is said and done, you've just added these two carbons over here, 1, 2. So we have 1, 2, 3, 4, 5, 6, and then 1, 2 to make a total of 8. In part B, we have we need to create a Gilman reagent. This time we'll start with a vinylic bromide. We can use chloride or bromide, it doesn't really matter. Lithium comes in, inserts itself in there, the copper associates with it. You'll end up with this Gilman reagent right here. 1, 2 carbons, and again, the lithium wants nothing to do with its electrons, so it's going to give it to the copper, but then the copper doesn't want to have a high electron density, so you can think of this as a negatively charged alkene. As a nucleophile. That carbon right there, let me just go ahead, there's a carbon here, there's a hydrogen right there, and now we're going to have a lone pair of electrons there, so this is going to be negatively charged. This is a good nucleophile. It's going to go ahead and do an SN2 reaction. The goal was to have a cyclohexane molecule. We'll put an iodide, some good leaving group on there, and this is a good, a very strong nucleophile. This is a secondary alkyl iodide, and remember, for secondary alkyl iodides, if you have a good base, that would actually do an E2 reaction, but with a Gilman, this is going to do an SN2 reaction. Go ahead and kick that off, and give us an SN2 product, where now we have that molecule right there, and the iodide comes flying off.